G'day and welcome to another vid. This one's Titans of Space, and yeah, I have seen a little bit of this, but not too much. So it's I suppose we'll have a look at it. Hopefully, I'm hoping to get through the whole lot in one go, but not really too sure. Sensitive to motion, no. Point and click, point and wait. Yeah, I think we'll point and wait. We'll get the full experience. What's this? Yeah, right, whatever. This version includes voiceover. Yeah, awesome. Continue. Okay, go back. Continue. Okay, what's this health warning? Oh, okay, it's just a load of blah blah. Music, headphones. Yep, check. Got all of them. Time. Okay, about 60 minutes. Oh, we'll give it a go anyway. Oh, cool. Let's do it. What's this one? Visit all planets most. Yep. Okay, full. Short tour 30 minutes. Same as full tour, but avoid stopping at all means. Short tour 30 minutes. We'll go to all the moons. Oh no, yeah, that's where I was up to. So we're going to start from the beginning again. Start full tour.
Welcome to Titans of Space. Take a look around and get a little comfortable. Over the next few minutes, we're going on a journey. Whenever you're ready, use the little blue triangle on the right side of your cockpit to proceed.
I don't remember it being looking this good. Time looks mad. This was the ready. Okay, options, question. Default trace, yeah, that zooms in. Nice. It's pretty cool. Cool. Why am I getting voice? I should be getting voice. I'm going to come back and just say, hang on, pause.
We've arrived at Mercury. Mercury is the smallest planet in our solar system and the closest to the Sun. It was not seen clearly until 1974, when the spacecraft Mariner 10 made a flyby, because it is rather difficult to observe from Earth. At first glance, Mercury might look familiar. It quite resembles the surface of the Moon. It is cratered and scarred by cosmic impacts. These similarities are superficial, however. Mercury is by no means a mere clone of the Moon. The surface of Mercury has unusual wrinkles, quite unlike those found on the Moon. And unlike the Moon, Mercury has an iron core which spins, generating a magnetic field. You might even say that Mercury has a moon-like surface with an Earth-like interior. Mercury has a mysterious orbit. Most of the time, when a satellite faces the much greater gravitational pull of a larger body close by, something called tidal locking occurs. This is a fancy term for when one side of the satellite or planet always faces the more massive body. The Moon, for instance, is tidally locked with the Earth, which is why from the Earth's surface you never see the other side. Since the Sun is so much bigger than Mercury, and since they are so close to each other, it was long assumed that Mercury was tidally locked with the Sun. However, for every 2 complete orbits Mercury makes around the Sun, it rotates 3 times. No other planet has a rotational period this strange. Temperatures on Mercury vary wildly. In direct sunlight, it can reach 426 degrees Celsius, or almost 800 degrees Fahrenheit. And in deep craters at the poles where the sunlight never touches, it gets as cold as negative 173 degrees Celsius. You might think that since it's the closest to the Sun, Mercury is the hottest planet in the solar system. Seems a reasonable assumption, right? You would be very wrong. Let's head to the next stop. This is the hottest planet in the solar system.
Oh, what? I didn't touch it. Oh, fuck. Shit. Sorry, guys.
Mars is the 4th planet out from the Sun, and it is one that has captivated people around the world for ages. It is a mysterious place, an evocative place. Mars is about 1/3 the size of Earth, and it is geologically dead, meaning the inner core is solid and it does not have any active volcanoes. It does have the largest dormant volcano in the entire solar system, Olympus Mons. Try to see it on the surface if you can. It's in the northern hemisphere. Mars also has a thin atmosphere, and evidence is slowly piling up that it had running water on its surface at some point in the distant past. It also has 2 tiny moons in orbit around it, Phobos and Deimos. We've landed many spacecraft on Mars, starting with the highly successful Viking program in the 1970s. Most recently, the rovers Opportunity and Curiosity have landed, and they are trucking around Mars as we speak. Curiosity was the most ambitious planetary landing in history. The team at NASA's Mars Science Laboratory had to devise an ingenious scheme to get the lander on the surface of the red planet. It was tricky because it is the size of a small car and weighs almost 2,000 pounds. They ended up using a parachute that transitioned into a sky crane that gently lowered the rover onto the surface, where it unfolded and began an epic mission that is still underway today. We are learning so much about this place that we could be here for hours. But let's continue. Our next stop is Jupiter, but we're gonna have to fly through the asteroid belt to get there. Don't worry, I think I can get us there in one piece, but you might want to hold on just in case.
I love how their sunsets are blue. That is cool. That'd be gross if that happened here. Well, I'm fascinated about Mars. It's just a planet itself, not its friggin'
Before we get to Jupiter,
conspiracy shit.
let's take a little break here to talk about Ceres and the asteroid belt. Ceres is what's called a dwarf planet. There are many dwarf planets in our solar system. We will meet a few others later on. Dwarf planets are tiny little planetary bodies that don't quite have the mass to qualify as true planets, but they're still bigger than asteroids. Speaking of asteroids, take a look around and you'll see a whole bunch of them. This region probably has millions of asteroids scattered in a belt that orbits the Sun between Mars and Jupiter. Though there are millions, the total mass of all asteroids combined is thought to be a fraction of the mass of our moon.
See something.
largest planet orbiting our sun. Jupiter is a gas giant, but you could also call it a failed star. It has 2.5 times the mass of every other planet combined. Its atmosphere swirls around at tremendous speeds, forming distinct bands that run along its latitude. Giant storms form at the intersection of these bands, the largest of which is called the Great Red Spot. It is a storm of unimaginable size and ferocity. Our entire planet could fit inside this one storm 4 times over. We don't know how long the Great Red Spot has been raging, but it was visible to the English scientist Robert Hooke in 1664, so it's been there for at least 350 years. Unfortunately, the Great Red Spot appears to be shrinking, so catch a glimpse while you can. Thought experiment time. What would happen if I launched you from this cockpit and you fell deep into Jupiter? Don't worry, I won't actually do it, probably. But let's assume I did. What would you experience? As you descended through the atmosphere, you would start to be whipped around by the extreme winds. It would be violent and chaotic. You might see lightning as the charged particles swirled through the upper reaches of the atmosphere. After time falling, however, you would notice a change. As you approach the center of the planet, pressure and temperature would start to rise. Eventually, the pressure would become so intense that the hydrogen around you would liquefy. Scientists think that this hydrogen ocean, at a certain depth, becomes compressed so strongly that the electrons are stripped off the very atoms themselves. This rapidly spinning central region of electrified liquid hydrogen could be the reason for Jupiter's incredibly strong magnetosphere. Jupiter is so large it has its own little solar system of sorts, like many of the other gas giants. There are at least 67 moons in orbit around Jupiter. 4 of them are large enough to be seen with a telescope, like the one Galileo used 400 years ago, and they are thus called the Galilean moons. Ganymede and Callisto are the largest moons of Jupiter. Ganymede, in particular, is the largest satellite in the entire solar system. It is 3/4 the size of Mars. It also has a very thin atmosphere of oxygen, but it's far too thin to support life as we know it. Ganymede has 3 layers, a core of metallic iron surrounded by rock and surrounded yet again by a layer of thick ice. There is evidence of geologic activity on its surface. The older, cratered areas give way in some places to younger, grooved terrain. But what caused these more recently formed areas? Scientists are unsure. The leading hypothesis paints the culprit as tidal warping, caused by resonance in the orbits of the inner moons. Basically, Ganymede might experience a greater than average tug at certain points in its orbit when it regularly lines up with some of the other moons. This repeated gravitational influence is called an orbital resonance, and it's very important in the story of many of the moons out here in the outer solar system. Callisto could not be more different in its history. It is the largest solar body to show no significant resurfacing since it formed about 4 billion years ago. It is also the most cratered object in the solar system. Its orbit puts it outside the main radiation belt of its mother planet, and that makes it a very likely candidate for a base of human exploration of the outer solar system in the future.
That was close.
Io orbits the closest to Jupiter of all its moons, and its surface reflects that fact. Its proximity to the massive giant warps and kneads it, like a baker would knead a roll of dough. These so-called tidal forces generate tremendous friction in Io's interior, The hot magma produced erupts constantly across its surface, leading to the heavily scarred face you see here. Io's close orbit produces yet another amazing phenomenon. As it swings around Jupiter, it cuts across the planet's magnetosphere, and this motion turns the entire moon into an electric generator. It can generate a current of up to 3 million amps, which then arc through space back into Jupiter's atmosphere and create lightning. This interaction between Io and Jupiter's magnetic field also strips matter off Io's surface, ionizes it, and sweeps it into a huge donut-shaped cloud called a plasma torus. This ends up vastly increasing the size and strength of Jupiter's magnetosphere. Io is a nightmarish but fascinating place. There is almost certainly no life here. But we can't say the same for Europa. Now, we don't know for sure that there's life anywhere other than the Earth. But if we were to make a list of the most likely candidates for life outside of our tiny blue sphere, Europa would be near the top. Why? Well, it probably has an ocean for starters. Europa's outer layer is most likely water, in the form of ice, but with a salty sea bubbling up from below through the cracks. There are what appear to be fault lines on the surface, and recent observations indicate it might even undergo plate tectonics, albeit with ice plates instead of rock plates that we see here on Earth. A dynamic environment with liquid water is an excellent breeding ground for life. We won't know for sure until we actually land a probe on its surface.
That was cool. Looks like looking at a jumper or something. Like material. Wow, that looks all marvelous in the left-hand corner there.
Look at that. This is easily the most spectacular sight in our little corner of the universe. Saturn's rings have been the object of fascination for as long as we've had telescopes. The first person to notice them was Galileo, and he, like many others since, wondered what they were. Were they smooth disks, or were they made up of particles? Where did they come from? We now know the rings are comprised of billions of particles, ranging in size from icy grains to rocks the size of mountains. The rings are arrayed in distinct bands that each rotate at different speeds. There are gaps between some of the rings, like the one that hosts the tiny orbiting moon Pan. Other gaps exist that we can't yet explain. The Cassini mission, still underway, should reveal more about this spectacular system in the coming years. Saturn itself is smaller than Jupiter, but it has its own system of dozens of moons, just like its larger brother. Like Jupiter, it has a small rocky core and is comprised mostly of hydrogen. Saturn has a strange formation at its north pole. Both of its poles have rapidly spinning vortices, but at the North Pole, surrounding the vortex, is a strange hexagonal band in the clouds. It spins with a period of about 10 hours and seems to be remarkably stable. Scientists are unsure how to explain this phenomenon, although it appears to be a standing wave, as similar patterns have been recreated in labs here on Earth during experiments with rotating fluids. For a long time, we didn't know there was a moon in this gap in the rings. We only knew there was a gap. But a gap in such a beautiful ring structure is probably caused by something. A tiny moon was a good candidate. Finally, in 1990, Pan was conclusively discovered and named. It is what's called a ring shepherd, because its gravity herds the particles around it, creating a gap in the ring. A tiny little moon in the shadow of a giant.
Yeah, it's cool. I like that. I was always just thinking about that. That is cool.
Mimas has the dubious distinction of having
Oh, what the hell?
Tethys and Dione were but specks in even the most powerful telescopes, until Voyagers 1 and 2, and later Cassini, passed them and photographed them in detail. Both moons are made of ice and rock. Tethys is another moon with a gigantic impact crater. Dominating its western hemisphere is the Odysseus crater, named after the warrior king in the ancient Greek epics, the Iliad and the Odyssey. The crater was, like the Herschel crater on Mimas, caused by an ancient monumental impact. It was a collision so violent it probably sent shockwaves clear to the other side of the moon, and might have created the Ithaca Chasm, a giant crack in the moon's crust which runs from the North Pole to the south. Dione is cratered, as many moons are after eons of cosmic impacts. But there is a mystery buried in this particular moon's history. In tidally locked satellites, one side always faces the mother planet. The most heavily cratered side of a planetary body should therefore be its leading side. In other words, the side that faces the direction of orbit. With Dione, the opposite is true. The most heavily cratered areas are on the opposite side to the direction of orbit. It's been proposed that, perhaps more recently, Dione suffered a collision which spun it around, but it seems to be facing exactly 180 degrees in the wrong direction. How very odd. Rhea is similar in size and composition to both Dione and Tethys, but orbits much farther out, so it does not experience nearly as much tidal attraction to Saturn. This means it lacks the internal heating of the other two moons, and has had fewer episodes of liquid water flow on its surface. As a result, the surface of Rhea is more cratered than that of Dione and Tethys. But where Rhea is similar to the other Saturnian moons, Titan is vastly different, and much, much more interesting. The second largest moon in the solar system, second only to Ganymede in size, Titan is larger than the planet Mercury. It has a thick, enveloping atmosphere that filters most light into a yellow haze. It's cold, with a surface temperature of about 289 degrees below 0 Fahrenheit. Water, in the form of ice, acts as most of the rock on Titan's surface. Titan is fascinating because it is, to our knowledge, the only other place in the solar system to have a cycle of liquids similar to our water cycle. On Titan, methane is a liquid, and it pools across the ground, forming puddles, lakes, and even seas. It rains methane on Titan, just like it rains water on Earth. Titan appears to have seasons, and the seas will shrink and grow in regular cycles throughout the year. The Cassini spacecraft contained a lander named after Christian Huygens, the 18th century discoverer of Titan, which descended in a spectacular fashion in 2005 via parachute down into Titan's atmosphere before finally coming to rest on the surface. The The Huygens probe descended for over 2 hours and transmitted data and images for an hour after landing. Is the largest of what are called the centaurs, or minor planetary bodies in the outer solar system. A centaur comes from the Kuiper belt, the vast cloud of comets and other bodies that surrounds the solar system beyond the orbit of Neptune. Every so often, one of these Kuiper belt objects is disturbed by the gravity of the gas giants and ventures closer to them. Their flirtation with our solar system is relatively brief on a cosmic scale, because they are in dynamically unstable orbits. Chariklo seems to be in an orbit that will take it closer and closer to Uranus as time goes on, and eventually it will either crash into the planet or be ejected out of the solar system once more. Take a look at Chariklo carefully. Look at its ring system. We only discovered them because of a happy accident. In 2013, Chariklo passed in front of a star from the perspective of our Earth-based telescopes. It was in that event that we discovered its rings. It is the smallest body known to have them, so Chariklo's rings are yet another mystery. It seems we've only just scratched the surface of all there is to discover in our neck of the cosmic woods. It is the first of what are sometimes called the ice giants. The weird thing about Uranus is that it is quite literally spinning on its side. No one knows why this is the case. It might have been caused by a cataclysmic collision in the distant past that knocked it sideways. Its 5 largest moons swing around in orbits that lie on the same plane as its rotation. This seems to indicate that whatever collision knocked Uranus on its side perhaps formed the moons as well. The thinking goes that the giant body that slammed into Uranus broke apart on impact, and the particles spread into a disk around the planet. Over time, particles in the disk collided with each other and accreted into the moons Miranda, Ariel, Umbriel, Titania, and Oberon. The other moons of Uranus are much farther out and were probably Kuiper belt objects that were captured later by the planet's gravity. As you can see, Uranus has its own faint ring system as well. Unlike the other planets we visited so far, Uranus was not historically seen as a planet, even though it is visible faintly to the naked eye. Because of its distance and its orbit, most ancient observers thought it a star, if they noted it at all. It wasn't until William Herschel described it in detail in the 18th century that opinion changed. Herschel thought it was a comet at first, but after its orbit was calculated, it was decided Uranus was a planet after all. The icy giant has 27 tiny moons known to orbit around it. Unlike most of the moons of the other planets, Uranus's moons are named after famous characters from Shakespeare and Alexander Pope's great works. Scientists suspect there are more moons awaiting discovery, but how many remains to be seen. There is much yet to learn about this mysterious giant.
Pretty cool. Pretty cool.
Miranda is, well, pretty weird. It has been called the Frankenstein moon because it looks like parts of several moons awkwardly pasted together. It has large regions of what are called coronae, or large oval-shaped upwellings on the surface. These may have been formed by warm ice pushing up from below. It also has tremendous fault canyons, up to 12 times as deep as the Grand Canyon. A rock dropped from the top of the tallest canyon, because of the weak gravity on Miranda's surface, would take almost 10 minutes to hit the ground at the bottom. Ariel seems to have the youngest surface of all the moons of Uranus. It doesn't have many large craters, only smaller ones. This seems to indicate that the larger impacts, which almost certainly occurred in the past, have been smoothed over by recent geologic activity. Tidal forces could potentially provide the heat for such activity. Titania and Oberon were the first moons of Uranus to be discovered. Herschel observed them both in the 18th century, and it wasn't until 1851 that Umbria was spotted by William Lassell. Titania is the largest of Uranus's moons, and the 8th largest moon in the solar system. Its surface is dissected by a series of gigantic faults, and it appears to be younger than that of either Umbriel or Oberon. Oberon is the second largest satellite of Uranus. Its surface is the most heavily cratered of the gas giant satellites. The geology of Oberon, like that of Titania, was formed by the interplay of two main forces, impact crater formation and what's called endogenic resurfacing, which is just a fancy term for geologic activity that is caused by internal heat. In Oberon's case, this heat was probably only a factor very early on, soon after the moon's formation. Umbriel has even fewer signs of geologic activity than the other two. It is heavily cratered like Oberon, and any activity swirling around in the interior has long since ceased in the billions of years since it was formed. We are now more than 30 times farther out than our own planet is from our star. It is cold out here. Neptune is an ice giant, just like Uranus, but it is slightly more massive. It is incredibly dense, denser than all the other gaseous planets. Neptune is also unique in that it was actually predicted to exist before it was ever observed. The astronomer Alexis Bouvard noticed in the 1800s that Uranus deviated slightly in its orbit from what Newton's laws of motion predicted. Rather than throw out the tremendously successful Newtonian framework, Bouvard decided to take the deviations at face value and see what they indicated. He predicted that another planet of about the same size must exist farther out in the solar system, and their mutual gravitational attraction would cause them to dance with each other as they swung around the sun. The effect would be small, but this mystery planet would perfectly explain the orbit he observed. On the 23rd of September in 1846, Johann Galle pointed his telescope at the part of the sky thought to contain the mystery planet, and he suddenly saw it. So Neptune was finally uncovered through the power of mathematical prediction. Its composition is probably similar to that of Uranus. Both are icy gas giants. Neptune does have the fastest recorded winds in the entire solar system. Winds on the planet can reach 1,200 miles an hour. So far, we know of 13 moons, but more almost certainly exist. Can you see the faint rings? They are a very recent discovery.
Notice how a lot of the particles in this.
Triton is the only large moon that orbits in retrograde, in the opposite direction to the rotation of Neptune. This leads scientists to speculate that it's actually a Kuiper Belt object that has been captured by Neptune's gravity. It has a thin atmosphere of nitrogen and methane, which is probably refreshed by volcanic activity. Triton is the only place other than Io, Venus, and the Earth which is known to have volcanic activity at the present time. We're a long way from home. Here you can see some of what are called the Kuiper dwarfs: Eris, Pluto, and their associated moons. When Pluto was discovered in 1930, it was classified as the 9th planet from the Sun. From the beginning, however, something was off about the little guy. For one thing, it had a very odd orbit. It was tilted off the plane of the solar system and was thus unlike every other planet. It was also much smaller than the other planets. It's more the size of a moon. It was only in the late 1970s that astronomers began to suspect that things out here were not so simple as they appeared. More small rocky bodies were discovered with equally eccentric orbits, and as time went on, the number grew into the thousands. Finally, in 2006, the International Astronomical Union formally defined what it means to be a planet, and poor little Pluto was left out. Pluto, like Ceres, Eris, and other such bodies, is now called a dwarf planet. We are in the Kuiper Belt, a vast swirling orb of comets and other rocky bodies. The Kuiper Belt is kind of like the asteroid belt, but much, much bigger, and at the edge of the solar system. Many of the moons of the gas giants, such as Neptune's Triton and Saturn's Phoebe, are believed to have originated from this region. And that was a tour of the planets. Now let's move on to bigger things.
Sun.
The Sun is a star. That might sound obvious, but it was anything but to the earliest skygazers. It is only with the tools that we have now that we are able to conclusively state that the giant ball of nuclear fire in our sky is the same kind of thing as every other point of light you see around you. Stars are essentially massive balls of gas that are constantly collapsing in on themselves. As they collapse, the atoms inside get squeezed together closer and closer, and eventually fuse together, which is a process that releases energy. This energy ping-pongs around the sun, eventually reaching a point where it breaks free and shoots off into space in the form of electromagnetic radiation, or light for short. A tiny, tiny fraction of the energy that the sun puts out reaches our little planet, but that's enough to sustain nearly every living thing that's ever existed there. That's pretty neat. From this vantage point, the Milky Way is particularly beautiful. Feel free to look around and marvel. There is no rush. The sun is absolutely massive compared to the planets in our solar system. About 1 million Earths could fit inside it. But the sun is nowhere near the size of some stars. Let me shrink things a little more to prepare for the next bit. Bear with me. There. Everything should now be 50 times smaller than before. This will make sense soon, trust me. Let's do a little comparing, shall we? This is the star Pollux. I'm gonna quiet down for a bit so you can take it all in.
That is huge.
Pollux is a star in the constellation Gemini. I've drawn a circle around where it appears in the night sky. Look up and to the left to see it. Pollux is what's known as a red giant. That means it is further along in its stellar life cycle than our sun is. But rest assured, the sun will get there in time. Pollux is a little under 34 light years from Earth, which just means it takes light about 34 years to get from here to there. Now that doesn't sound like too long a time, but consider that light travels over 186,000 miles every second, and you can start to imagine how far away Pollux must be. Pollux is large, don't get me wrong, but there are things even more massive out there.
It's fucking massive. Fuck, man, this is all new. I didn't even know this planet even existed.
Feel the heat yet? You're looking at the blue-white supergiant Rigel. Rigel is the brightest star in the constellation Orion. Look directly to your left to see where it is in the night sky. It's about 860 light years away, give or take a few dozen light years. Rigel's color comes from its extreme temperature. On its surface, it can reach 12,000 Kelvin, and it is getting hotter every day. Rigel, like other blue-white supergiants, has already burned through the hydrogen in its core and is expanding on its way to a fiery end in a supernova. Rigel is enormous and so powerful it boggles the mind. But it's nothing compared to what's next. We call this VY Canis Majoris. It's not normally visible to the naked eye, but I'll circle where it's located anyway. Look to the left of Rigel. This star is so huge, its gravity is crushing its core in an unsustainable way. Hypergiants like this don't last long. It's estimated that Canis Majoris will explode violently and collapse into a black hole within 100,000 years. Maybe it already has, and the light just hasn't reached us yet. Sometimes we reach a point where words are inadequate. I think this is one of those times.
That's insane. That's insane. There's nothing I can say. It's crazy.
We need to take care of this tiny little blue-green rock. We need to take care of each other. To paraphrase the late Dr. Sagan, it sure seems that no one is headed our way from far away to save us from ourselves. I've shown you the solar system, and I've shown you the sizes of stars as compared to our sun. Now let me show you everything to scale. No more toy models. It's about to get real. We are now as far from the sun as our home planet really orbits. But what about the other planets? How far away are they? This is our entire solar system to scale, with the sun at the center. I hope you're beginning to get a sense of the immense amount of space there is between each planet. But what would happen if, say, Pollux replaced our sun? If Pollux replaced our sun, the planets would be flung wildly out of their orbits, and life on Earth would be incinerated. But from our perspective way up here, not much seems to have changed. What about Rigel? If Rigel were at the center, it would engulf Mercury, and its immense gravity would start to draw all the planets towards it. It would be even worse news for our solar system. Look, I know what you're thinking, but it's a bad idea. Putting Canis Majoris at the center might have unforeseen consequences. All right. Just this once. I probably should not have done that. I think we're safe up here, but there's no telling how long we will.
Awesome. That was cool. That was absolutely awesome. A lot better than what I thought it was going to be. Very, very educational. Didn't think it was going to be that educational, but there's nothing wrong with education. That is awesome. That was awesome. Cool. All right, I'm going to wrap it up because it's probably been about an hour. I don't know. I just have no idea what time it is or how long I've been in these things when I'm in VR. So I'll end it now. So thanks for watching and catch you next time.